everyone, I'm Sarvenaz, and this project explores how EV adoption and charging infrastructure have grown across Canada from 2017 to 2024 and what 2025 could look like. Before diving into data, here's a story behind why this topic was chosen. I chose this topic because I wanted to study something meaningful and data rich. Canada's EV adoption reflects real progress in sustainability. I wanted to build a province by province, evidence based view of how fast EVs are growing and whether charging infrastructure is keeping up. It's both a story about data and a story about policy impact, combining analytics with real world planning relevance. Let's look at where the data came from. The analysis combines three open datasets. I gathered EV registration counts, provincial populations, and public charger data, then standardized them to a yearly timeline for consistent comparison. Through EDA, I ensured data integrity and alignment before merging them into a single harmonized dataset for modeling and Tableau visualization. Now that we know the sources, here's how the data moved from raw files to insights. The workflow followed a clear structure: data cleaning and transformation, exploratory data analysis, metric creation, and visualization. The processed outputs were exported to Tableau to reveal year over year adoption and infrastructure patterns across Canada. Next, let's look at the current landscape, how adoption compares across provinces. In 2024, Quebec and BC clearly lead EV adoption, around 20 and 9 EVs per 1,000 adults, respectively. The national average is 8.7, with most provinces below that. When we normalize by adult population, we see real performance differences, which align closely with charger availability and provincial incentive programs identified during EDA. Here is the same story shown spatially. This map reveals clear regional contrasts. Densely populated areas such as Quebec and BC appear darker, reflecting stronger adoption, while provinces such as Alberta, Saskatchewan, and Manitoba remain lighter. The spatial trend follows both population concentration and charging network coverage. Let's step back in time and see how adoption evolved. This chart shows how adoption accelerated after 2021. The inflection point coincides with federal rebates and provincial EV mandates. Our time series EDA confirms a steady national rise, while leaders like Quebec and BC maintain exponential growth above the mean trend line. The dashed gray line represents the national average trend. To make those trajectories clearer, let's separate them province by province. This grid gives a clean province by province view of EV adoption. The consistent upward slopes after 2021 confirm broad-based growth with stronger acceleration in leaders. It's especially helpful for spotting provinces with late starts but improving momentum. Ranking helps visualize momentum differently. Here, we see how each province's rank evolved year over year. Quebec and BC hold steady leadership at the top, but Yukon and Prince Edward Island show strong momentum once charging infrastructure reached critical density. This ranking view captures the competitive diffusion of EV adoption nationwide. Now let's connect adoption to infrastructure directly. This correlation plot illustrates the direct link between charger density and EV adoption. Each point represents a province scaled by population. The positive slope of the trend line confirms that regions with denser charging networks tend to have higher EV uptake, validated by a Pearson correlated coefficient above zero point 0.8 in our EDA. Adoption drives demand, but how does that pressure the network? This slide translates adoption into capacity pressure. The bar chart shows 2024 EV per port ratios, while the heat map tracks how they changed over time. Lower values mean better accessibility, and leaders like Quebec and BC have kept their ratios stable, showing that infrastructure has scaled in sync with adoption. Uh, so, so why does all of this analysis matter? The reason behind this analysis was to link data insights with real infrastructure planning. By quantifying EV adoption and charger density, we can identify gaps before they become barriers. Forecasting helps policymakers and analysis plan investment for equitable access across provinces. With that foundation, let's look ahead. What could 2025 look like? This chart visualizes the forecasted EV adoption through 2025. We see Quebec continuing its lead, followed by BC with noticeable upward momentum. These projections follow the same momentum detected in earlier EDA, confirming that provinces with stronger infrastructure continue to widen their lead. To trust the forecast, the model behind it must be both fair and accurate. The final model applied a weighted ridge regression with province fixed effects chosen for both its interpretability and fairness across provinces of different sizes. Ridge regression helps control correlated predictors like charger density and population, while weighting ensures that larger provinces like Ontario and Quebec don't dominate the model. This approach lets every province's unique policy and behavioral context contribute proportionally to the predictions. The model achieved an R squared of 0.9 on total counts and 0.8 on per capita values, with a mean absolute error of 1.28 EVs per 1,000 adults, indicating a consistent high accuracy fit for 2025 forecasting. With the modeling complete, here is what the data tells us. The analysis shows that Canada's EV adoption is expanding faster than ever, especially after 2021. Correlation analyses confirm that charger density has the strongest link with adoption levels. Provinces investing early are now leading nationally. Quebec and BC continue to set the benchmark, while other provinces have significant potential if infrastructure keeps scaling. The 2025 forecast reinforces that growth trajectory, suggesting steady nationwide momentum toward electrification. Let's bring everything together. This study provides a clear data driven picture of how EV adoption and infrastructure have evolved across Canada. The results emphasize that charger density and supportive policy are key accelerators of adoption. The combination of Python, scikit-learn, and Tableau created a complete workflow from pre-processing and modeling to visualization and forecasting. Future work can expand this analysis by including policy intensity or charging usage data to refine predictions and guide sustainable infrastructure growth. For those who'd like to explore the project in detail, the full analysis is available on GitHub, including code and process data. The Tableau dashboard complements it with an interactive overview of adoption and infrastructure trends. Both can be accessed by scanning the QR codes in screen. And finally, thank you for watching this presentation. The project reflects a data-driven exploration of EV adoption and infrastructure development across Canada, built through open data and transparent modeling. I appreciate your time and interest. Thank you.